Choice 2, 10th of September.
I resign.
Action.
Oh, but it's no good resigning after you haven't done it. Okay. All right. So please don't all be absent tomorrow.
What is the coach not now?
May I introduce you to my good friend Zero? Okay. But glad you know what a zero is. Okay. All right. And Emma. Tomorrow when you guys, at the end of me teaching you stuff, and you're about to start the activity, remind me that I have to send the activity to Ethan and Katie. Okay. All right. Okay. So this is the second indirect technique. What's the matter? Oh, just die quietly in the corner.
I would love to.
Okay. Are you focused or are you now all unpacking?
Yeah, I'm happy. Man, did you use the word mingle? On the point that I'm reading, it was like to mark animals are then released back into the population and left to mingle. What else did you use? Man, that's that word. Tony. It's true.
Is it a bad word?
No. Man, it's just such an interesting use of word. You're an like instead of just communicating, interrupt, mingle.
Okay, some people are starting to worry about our class. Okay, so let's just pretend we're normal humans and that we're nice people.
Just wait until we have to do human reproduction. This one.
Okay. Fortunately, we're not actually going to get to matric because we're not going to finish grade 11 at this rate. Okay, so this is called the mark recapture technique, or occasionally the capture mark recapture technique. Don't worry about it. I'm fine if you call it the mark recapture technique. Okay, right. It looks pretty complicated. It isn't. So I'm going to skip this slide and go on to the next one, and then you can read this afterwards. Okay. All right. Sit dead still and look at me and listen. Okay. So this technique is an indirect technique because each individual is not counted, but a sample is counted, a formula is applied, and an estimate is achieved, which is why it's not a direct technique. Okay, and it involves the following process. Now, we are only interested in one species of organism. So, just like yesterday on that sheet, you only counted the mellinus. You completely ignored the other ones. It's exactly the same. You only count the species in which you are interested. You completely ignore the other ones. You do not let them die. You throw them back. That'll make sense tomorrow. Okay. So, let's say, for example, you would like to count how many ants there are in the kitchen or wherever. You grab a handful, and that handful is called sample 1. You count them. You record that number in a table. And then you mark them all. So let's say, for example, in sample 1, I have 27 individuals. How many are marked? 27. Say again? 27, because you mark them all. Okay, you happy? Everybody understand?
Yes, ma'am.
Okay. You throw them back. just grab some roller time. Okay, listen to me. Hey, not watching there, watching here. You throw them back. You allow them to mingle with the rest of the population. Okay, or mix if that's what you prefer.
I was going to say interact.
No, you don't necessarily need them to interact with, you just need them to mix with. Disperse.
Oh, that's fine.
Okay, next time I need my notes rewritten, I'll ask you guys. Okay, all right, you happy with that? The time that you give them to mix depends on the kind of organism you're looking at. If you're looking at a population of snails in your garden, you would leave them for about a week to mix with the rest of the population. If you're looking at ants in the kitchen, you leave them for about 2 hours. So do you see that the time that you leave them to reintegrate into the population is dependent on the type of organism that you're sampling? Okay. All right. I had something to tell you at that point. Okay. You then take a second sample. Okay. You count them. Okay. Would anybody like to give me a figure?
12.
Good.
So maybe you just like get a handful. It doesn't matter how many you just.
Well, you hardly get a handful of elephants, but you
Yeah.
take some.
It would be a problem with the elephants. Depends on the animal you're looking at. Oh, I know what I wanted to say to you. That this method only works with organisms that move.
So you can't do the trees.
They struggle to mingle.
Yeah.
Okay. Of this second sample, you count how many are marked. Simpiwe, give me a figure.
6.
What symptoms do we have here? Oh, did you say some kiwi? I thought you just gave me a figure.
I did, I said Simpiwe, give me a figure.
My bad.
Yeah. All right, you repeat sample 2 a number of times. You're still going to call it sample 2. You throw this sample 2, you throw it back. How many do you throw back, Simpiwe?
6, man.
Dude.
What?
20.
12.
But you marked 6.
What are you going to do? Let the other 6 die?
No, but why did you only mark 6?
You didn't mark them.
Only marked 1. Never mind.
Wait, you counted. So what is the 6?
Counted 12, and then from that 12, there was only 6 that were marked from that 12.
Oh, the 6 were marked.
Already marked.
Yes, yes, from sample 1.
I'd love to see what this table would look like.
Okay, right, we happy. Repeat this sample 2 procedure after you've thrown them back and given them enough time to integrate, disperse, mix, mingle, okay? And you repeat this, I don't know, 5 times. Total, how many times are you doing it?
6.
Good.
Ah.
Does that count sample 1?
Yeah.
You-
Yes.
No, it doesn't.
No, you're only doing sample 2s.
Sample 1
You
was
do
original.
this one, and then you repeat it 5 times, so it's a total of 6.
Emily! I understand that bit, but what happened before?
You took 27, you marked them, you let them free.
But then why did someone say that it doesn't count?
Oh, you're not including that. I'm talking about you now doing the procedure with sample 2. So you take a second sample, you count them all, you record that figure in a table. You check of those how many were marked. You record that in the table. You throw all of sample 2 back, you allow them to mingle. you take a second sample 2. So I said to you, do sample 2, I explained sample 2, and then I said repeat that 5 times. So that's a total of 6 times you do the sample 2. Does that make sense? Because some of you didn't get it.
Because it said another.
Okay, Jessie,
Yeah.
you failed grade 11. So you've done it once. You repeat it 3 times. How many times do you do grade 11?
Oh no.
Ma'am, do we then just label it sample 3, sample 4?
No, you just call it sample 2. First one, second one.
What do you mark them was? Yeah.
We'll get there, maybe. Okay, you repeat sample 2, say 5 times. Each time you get a sample, you count them, and you count how many are marked in that second sample. Emily,
11.
how many are marked?
7.
Do you mark any of them?
No.
No. Now what do? You record this information in a table, you throw them back, you allow them to mingle. You keep on doing this. How many times are you going to do it?
6.
Good. Blah, 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 blah. Average.
Shimon, do you include sample 1 in your table?
No. Yes, in the table. Okay. What is the average number of the sample 2? Shanaiki?
10.5.
Oh.
Because if you've got 6 things, you can get an uneven. Okay. How many were marked on average in the second sample, Shanaiki?
9.
Okay.
I don't know.
Okay. Everybody happy with that? Everybody understand what we're doing? Okay. Did you include sample 1 in the average?
No.
Okay. Yay, finally. Okay. Right. Look at this and do not write. If you write, I will beat you. Okay. You then apply a formula. This particular formula is called the Peterson's index. So I think it was Mr. Stroke Mrs. Stroke Doctor Stroke Miss Stroke anything in between Peterson who invented this.
It's Peterson.
Ed Peterson. You must give the full formula. So those cretins who wrote A equals L times B.
That is the formula.
Yeah.
Formula says
area
area
is equal to L times
If you look on a formula sheet, it doesn't say area equals length times
No,
breadth.
that's
It
in
says
some
L
funny subject.
No,
In this subject, you write the
but
full
it's a maths
formula.
formula. Therefore, it has to be L times B. Like a
We're going to write length times breadth.
That's correct.
No, I don't agree.
none of us are doing
Everywhere else,
that.
we've just done L times length times breadth. Everywhere else.
I don't mind. I ran out of pink pen because I was going and writing naught.
Just marked it right.
Is that where we lost marks because we didn't write the formula?
One of the places that you lost marks.
No,
So we will lose marks if we don't put the formula.
For the rest of your life, you will lose marks every time you don't put a full formula. Don't fight with me. Just listen to what I'm saying. You can talk till the cows come home. I'll be going.
No.
I'm still going to give you naught.
But no, we didn't.
No, don't care. Yesterday in class, I said to you, formula, write the full formula. I gave you the whole story. I said, put units of measurement all the way through. And you go,
You didn't talk to me about formula.
I do. It's always here.
Ma'am, I really thought you were talking about
This one, that's the
that one.
And that no, it's in every single thing. Yes, you kids are going to drive me to drink.
formula for math is length times L times B. That's a
Keep going. I don't care. I'm just going to keep giving you naught. Okay.
Do we write L times B?
No,
Then welcome to write L times B, and I will write 0.
Oh, okay. I understand now.
Okay.
Sorry.
It's fine. Okay. You must give the full formula. And if there are units of measurement, you give units of measurement the whole way through. You don't just thumb suck at the end, centimeters squared. Okay. Just because in that funny subject downstairs, you thumb suck, you go like pounds and this and
So
acceleration, and then you come up with newtons. No.
No, but like area, the universal thing is measured in centimeters squared, meters squared, kilometers squared. Universal, whatever subject, so must we not write that in bio? Like must we try
She's saying that when we do the calculation, so when we do length times
Like
breadth,
4
we say
centimeters times 6
4
centimeters
times
equals 24 centimeters squared.
Yeah, that's right.
So you have to put the unit next to the number.
Yeah, that's what I'm saying.
That's what I'm saying too.
Now I'm still out about length times breadth. Did everyone get it wrong? Like the whole bio?
No, the clever class got it right.
But they were telling us they got it wrong.
No, we not you, sorry, I didn't. Right, length and breadth, because I just know from
It doesn't matter now, guys.
Okay, thank you. Okay,
Just will know for exam
Yeah.
and the future.
all right. Okay, so there we go. Now I'm warning you because you're going to whine about this tomorrow as well. This is abbreviated. I have given it a key because it's really long. And if you write the whole formula, it like falls off the edge of the page. So you can write it as an abbreviation and you give a key. You will notice that if you look for this formula, Peterson's index, in about 5 different places, they use different symbols. It's fine. In fact, I think the notes give different symbols from what I gave here. The issue is that you've given a key.
So we have to write that when you write the formula.
You don't have to.
So we have to write that, then do that, and then put the values in. That whole thing.
No, you can only write every second one. Tony will write every alternative one, you write every second one.
I'm just sitting in my office.
Don't why do kids fight with me all the
No,
time?
I'm not fighting. I'm blatantly asking. Do you have to write
And
that?
I blatantly told you, yes.
Cool, thanks.
So then we can use this one in the book.
Yes, absolutely. As long as you give a key, babe. Okay. So what this says is population size, estimated population size, equals number of organisms in the first sample. That number. Multiplied by number in the second sample. Look carefully. This number. It's an average. It's an average. This number. Because you repeated the second sample to make it more reliable. Okay. Divided by the number marked in the second sample. Look, this number, this average. Okay? So that times that divided by that. Then it appears that the fact that I spent 30 years at the beginning of this section saying to you, every single time you write a scientific name, you underline it. You went, underlined it. Why?
What's it? Oh, it's the
Ah.
Try. In the formula.
Ah. Everywhere.
Try.
In the heading,
Well,
in the...
it was underlined. Yeah, because of the heading.
Oh. That's the heading is underlined. You underline that and then you underline the heading. You kids want to pass matric or don't you?
Would love to do it.
Yeah, well then best you do what I tell you to do. Okay. All right. To increase the reliability. Okay. To increase the reliability, two things. Reliability, remember, begins with an R, so it's the repeats. And you did it in two different ways. One, you repeated sample 2. And secondly, to increase the reliability, you should get a figure at the end of this thing and repeat the whole process,
So would you get the same?
but marking them in a different way. No, you'd get different.
So would your sample 1 still be the same number or would it be a different number?
No, because then all you're doing is increasing sample 2. So you would need to mark them in a different way and start right at the beginning, sample 1, mark them differently.
So you repeat the process 3 times.
The whole process.
And then would you
Or we
add
could-
that?
Yes, including sample 1. And don't say repeat more times, because I will repeat giving you a 0. You say repeat and you give me a figure. You say repeat 3 times and get an average. Or repeat however many times and get an average.
So remember, this repeat at the end 3 times is now that, because we had 27 originally, now we've got our average. We chuck that table and we start a new one.
Yes.
Collect a whole bunch of ants again. And
Yes.
It could be
But mark them differently.
in pink, let's say.
Yes. Yes. Yes.
You leave the
There's
one
now
that
18, and then we then throw
Yes.
them, we leave them again, we collect
Yes.
them again.
So you do the whole process again with the pink mark
ones.
ones. Yes.
Do you leave the ones that you did the first time in there, like marked? Do you leave it?
You can, because you're now using a different kind of marker.
So you mark them again, if you get, no, if you get one that's already marked, you just mark them again with a different
Yes, absolutely.
colour.
That's fine. Yeah.
Shame, draw
Well
the
done.
ants.
Okay, everybody happy? Everybody understand? You sure you understand? Okay. So, we need to talk about the process of marking. So this is an example of a butterfly. It's not a moth because it has clubbed antennae, not feathered antennae. That makes it a butterfly, not a moth. And this is an example of a method of marking.
Imagine learning your entire life to adapt to your surroundings, to hide from your predators, and some idiot comes and draws a big cross on you. It's making you stick out. Like you're like, I can blend in, and some idiot's like, cross!
That's surely cute. That can't come off. The poor thing. It's like animal abuse.
They live about a week.
I'm serious. Why?
Did you not keep silkworms in your youth?
Yeah, but that's not a silkworm. That's a butterfly.
Silkworm, moth, butterfly, same thing.
What thing?
They don't live very long.
And yet there's everywhere.
Yeah,
Moths are everywhere.
Okay, right. This is critical. Okay, so precautions to ensure accuracy. And first of all, I'm going to talk about all the stuff to do with marking. So Tony was quite right. She might be surprised to hear this, but Tony was correct that it's terribly, terribly important that that marking mustn't affect the animal. So if the animal that you're sampling was a type of fish in a dam, you can't mark it with a lead weight around its neck, because then it sinks to the bottom and it dies. So then it's not mingling with its buddies.
mingling in the sky.
Okay, everybody happy? Okay, so the marking mustn't affect the animal. Okay, all right. Secondly, the mark must not wear off between samples. So, who's got a younger sibling? Okay, you cannot decide when you are sampling fish in a dam to go, my sister's got paint, and go and get your little box of water paint from your sister and paint a little X on the side of your fish and then throw it back in the water. It's not, it's going to wear off. It's going to wash off in the water. So you've got to be very careful and choose the method of marking very carefully. The individual must be able to mix with the rest of the population after sampling. So don't go and paint it neon green and then all the other fish go and sit in that corner and leave your fish sadly on its own little lonesome over there, because then it's not mixing. Okay, so however you mark it, it must be able to mix with the rest of the population. Okay, the population must be closed. No immigration, no emigration. No births or deaths can happen during the investigation. So you all going, how are you going to prevent that?
No sex. Say to them.
You don't have births straight away after 6, thank God.
Well, like ants. Probably just have one day to be pregnant.
Okay,
You do they like to say it in
so,
No.
no. So what you would do is, Tony, just leave it. What you would do is, to ensure no births and deaths, is 2 things. It can't go on for too long. If you do it over a year, there will be births and deaths. And the second thing is, choose the time of year in which you do it very carefully. If you know that impalas give birth in spring, and the majority of winter is when the majority of deaths occur in winter, don't do it in spring and don't do it in winter. So do it in late summer. Then no births, no deaths. Okay, you happy with that? Okay. All right. The chance of an animal being caught must not change as a result of age or experience. And this is something like, if you choose a trap as your method of catching them, and you know that many animals, once they've been caught in a trap, even if they're not necessarily injured, will not go anywhere near there again. So then you've got no chance of getting that animal in sample 2. And that can't happen. So you would have to use a method of catching them that wouldn't give them an experience thing that they wouldn't not be caught next time round. Okay. All right, everybody 100% happy. So the mark recapture technique involves sampling a population of animals and then marking all the individuals captured in a recognizable way. Okay. They're then released back into the population and left to mingle for a suitable period of time. Once they become thoroughly mixed into the population again, the population is resampled. So this is sample 2. And the assumption is that the proportion of marked in the second sample is the same as the proportion marked to non-marked within the whole population. And that's why you can apply a formula. Now, don't worry about this. Just worry about how to do the process. Okay.
So how are we going to do a test on this? Because we can't really do the actual thing.
Really?
Or can we? What are you going to use? Animals.
Ants.
So with our sample being 27 in the beginning, sample 1, is that 27 out of how many? So we don't know.
No, we don't know. Well, the whole thing is we don't know.
We don't
Otherwise,
know.
why are we doing this thing?
I was going to say, so we don't know that how many. So we're just going to take, let's say there's X, we don't know how many antelope or children in this class. You take 5. You then spot them up and you let them loose in the classroom. You then take another 5, or you take 8 afterwards. You just
Your second sample's not the same size as your first. It's just how many you catch.
So you can just pick a number. You can be like 9.
No, you don't have to pick a number. So if you're doing it on fish in a dam, first sample you take a net and you go whoosh, that's your first sample. You throw them back.
Your
Second sample, whoosh, count them. There's not a desired number for your
So
second
there's no like
sample.
odd number chart that you could be like, there's 8 elephants here. Whoosh! Like,
It's difficult to capture your elephants in a net. Yes, Erin,
Ma'am, from sample 1, you mark all 27, right?
that's
And
correct.
then, okay, then
How do you mark ants?
The little dot of bright pink nail polish on top of their head.
Serious? Are you serious?